Welcome back. Today we're going to look at applications of right triangles. So first let's practice just solving for a right triangle. So if we're given any right triangle here and we have some information about it, we have A equals 20 degrees, C is the right angle, and B is up here. And we're also given a side B is 15. Remember that side is going to be opposite of angle B. Well, we can find those other sides pretty quickly and the angle just by subtracting this from 90. So 90 minus 20 is just 70 degrees. So we know that angle is 70. And then a quick review, we can find these other sides just using our trig function. So tangent of A, which is 20, would be A over 15. So A is going to be 15 times tangent of 20. And that's about 5.46. And then we have, for C, we can use cosine. Since we have the adjacent side, so 15 over C, so C is just going to be 15 divided by cosine of 20, and that's approximately 15.96. Okay, let's practice drawing some pictures. So here we have an angle of elevation problem, and we're looking at a building with a steeple, so a church. So here we have, we're going to be 65 feet from the base of this building. And here's the church you could see with the steeple. Here's the bell. And you have two angles of elevation. So you have the first one to the bottom of that steeple is 35. And then I'm just going to use a different color, which is always helpful when you have overlapping triangles here. And the second elevation is 43. Now we want to find the height of the steeple. So we're definitely going to have to make two different triangles. That's pretty easy. So looking at the first triangle here, we have, I'll make this X, and I'll make the height of the steeple H. So we can write two functions here. So we have the tangent of 35 is going to be X over 65. So I could just rewrite that as X is equal to 65 times tangent of 35. And then if I look at the bigger angle, tangent of 43, well, that's going to be equal to X plus H over 65. And I'll just rewrite this so we can isolate H, because that's what we're trying to solve. So X, let me just write that here, H equals 65 tangent 43 minus X, and well, we already figured out X here, so I could just plug that in. And I'm just going to subtract it here, 65 tangent of times the tangent of 35. So that's approximately 15.1 feet. All right, just using overlapping triangles. Now let's get to bearings. And so when we talk about bearings, we're actually going to have some angle measures. So there's really two different types of bearings. In general, we're using bearings in terms of north, west, south, and east, north, south, east, and west, all the directions. And in general, you always state the north or the south first. If you could tell these quadrants, you said, so you have north, west, and then northeast. And then the third quadrant here, southwest, southeast. So we're first defining that path with north-south, and then using east and west to draw those acute angles. And we never use the north, south, east, west. It'll always be an acute angle. Now, true bearings, also known as azimuths, are used from 0 to 360 and go clockwise. So just looking at this protractor here, you could tell. So if you're always going to start north for true bearings, and then you're going to open that angle and go in a clockwise rotation, okay, until you get to 360. Okay, let's determine the bearing for each of these angles, and then we'll look at the true bearing. So remember, first we're looking at whether it goes north or south, and it's closest to the south. And then this acute angle would just be 90 minus 20, which is 70 degrees east. For the second example, it's closest to the north, so we're going to start with north, and then it's given right there 43 degrees west. For C, we're going to start north, and then we have to look for this complementary angle. So when we have 90 minus 35, that's just going to be 55. So 55 degrees east. Now let's look at the true bearing, or the azimuth. So remember, we're always going in clockwise rotation, and we're starting with the north. So we start with the north, and you can just tell that that's a right angle. So it'll just be 90 plus 20, so that's just 110 degrees. For this one, we're always going to start north, and we don't go negative. We don't say negative. So all we're going to have to do here is just subtract 43 from 360, so that's 317 degrees. The next one, again, you're starting north, and we did find this angle before. Remember, we said that was 55, because 90 minus 35 is 55. So this will just be 55 degrees. All right, let's do some practice. And for each of these, I actually would encourage you to practice them and try them out, and then check your answer, because probably the most difficult part is just drawing the picture. Okay, so let's look at here. We have a sailboat leaving a pier, and it's going due west, 8 knots per hour. So I'm going to draw the pier over here, and it's going 8 knots per hour. So after 15 minutes, so that's a quarter of an hour. So 1/4 of 8 is just 2. That's 2 knots. And then from here, after 15 minutes, the boat changes course, north 16 degrees west. So I'm just going to draw a little compass here. So it's going to go head north, but remember, we're going 16 degrees west, so that's just going to be a little bit to the left here, and that's going to be 16. If that's 16, then we know that this whole angle would just be 16 plus 90, so that'll be 106. Well, let's look at here. So it says this boat is going to travel, it says, at 10 knots. And so when we think of this one, 12 minutes after, on this course, okay, say after 12 minutes. So 12 minutes is 1/5 of an hour, so we'll just divide 10 by 5. So that's also 2 knots. So let me just draw this a little bit longer. We have 2 knots. And so from here, we want to actually figure out where the sailboat will be in relation to the pier, and then also its distance. Okay, and for all these problems, you notice right away that this is not a right triangle. So we want to try to find as many angles as possible, and then find a right triangle. So if you know that this angle is 106, and you actually know that this is an isosceles triangle, here's some geometry going back, then you know that these two angles are 37. So if those two angles are 37, what we can do is draw a right triangle here. Okay, we can drop an altitude. There's a geometry term. Okay, so we're making a right triangle. Remember, this is the right triangle trigonometry, chapter 4. So we're going to draw this right triangle. We want to find this whole distance here, but I have to just find one side at a time. But I know that it'll be double. So if I know that this angle is 37, well, the cosine of 37 will equal x over 2, right? This is the right triangle. So we know that x equals 2 times the cosine of 37. So we know this distance d will just be twice that. So this will be 4 times the cosine of 37, which is about 3.19 knots. And that makes sense because we have the other two sides are 2, so it has to be a little bit longer. And then looking at this angle, we're trying to figure out what is the angle relationship. And so let me just pick a different color here. So we always want to redraw that angle here, that 90, the north, south, east, west. And remember, this is given in terms of north, south, east, west. So we want to figure out this direction. So we're going to start north, and we have to find this angle, which is just going to be 90 minus 37. So this will be north, that's 53 degrees west. So there's the direction, or the bearing. Here is the distance from the boat, just up here, to the pier. Okay, let's look at this last problem. Again, I do encourage you to pause the video, try it, and then come back to check your answer. So we have up here, New York City, and it's in a direction of 235. So we know that 235 is in the third quadrant. So this will take us that. And this whole angle is 235, but we know that if this is 180, well, if I subtract 180 from 235, this will be 55. Okay, and then it says Princeton's down here has a they're going to be approximately 51 miles apart. What we want to find is how far south, how far west. So we can actually just draw a right triangle here. That's easy. So this is I'll make this my south, I'll make this my west. And we want to figure out the bearing from Princeton back to New York City. So when we look at the south first, well, I can use this 55, and so I know the cosine of 55 equals the south over 51. So my south will just be 51 times the cosine of 55, and that's approximately 29.25 miles. And then over here, I'll write the west. So looking for the west, I'm going to use the opposite. So what's that going to be? Sine of 55 is going to equal the west over 51. So this will be approximately 51, well, exactly 51 times the sine of 55, which is approximately 41.78 miles. So we have the south and the west, the total distance, and what we want to figure out is just this angle coming back. And what I always like to do is make sure that you draw those north, south, east, west, and you can tell that these two lines here are parallel, and it's pretty easy. We have this is 55, so this angle in here will be 55, alternate interior angles, right? So we always know it when we start with the direction. This is in the true bearing form, so I just need to write 55 as my true bearing.
Well, I hope this lesson was helpful, and I'll see you all in class.